Hello guys, welcome to Backbencher Studies channel. In the last video, we have discussed how to solve problems based on signal flow graph and based on Mason's gain formula, and how to find the determinant of this signal flow graph and the isolated path determinant also. So let us quickly do another problem which is very easy and which was given in gate. Here it is uh, the overall transfer function of this given figure over here, and it is given that the input signal is x1 and output signal is x2. That is also given, I forgot to mention. So how to do that? So first step in this Mason's gain formula is to find out the forward path, and this, as this is a very simple signal flow graph, we can say there is only one forward path, that is P1 equal to 5. So by taking that, we have one forward path gain, that is 5. And going on to next step, we have a loop. We have to find out number of loops and loop gains. We have only one loop, that is the also the self loop. Remember, a self loop is the one which uh, which have only one node is involved in the entire loop. So we have a self loop of loop gain zero point 0.5. So let us mention that we have this loop gain of zero point 0.5, and in the next step we have to find out this isolated determinant. So how we do that, we already discussed. We should based on path gains, we have isolated determinants. If we have two path gains, then we have two isolated determinants. So we have one path gain over here, so we have one isolated determinant. So by isolating this path 1 p1, so if we, what do you mean by isolating? Like we have to delete this forward path. So if we delete this forward path, the p1 equal to 5, there is nothing left in this signal flow graph. And whenever there is nothing, no loops are being left, whenever the path is isolated, we have this determinant equal to 1. So del 1 equal to 1 minus 0, that is 1 only. And next we have to find out this overall determinant of the signal flow graph. So we have only one path and one loop. So we have overall determinant del equal to 1 minus sum of loop gains. So we have only one loop. So there is no possibility of non-touching loops here. So we have 1 plus L1, 1 minus L1, that is being the del. So we have 1 minus L1, that is zero point 0.5. We have the determinant as zero point 0.5 over here. So we have the entire specifications of this signal flow graph. Now we can use Mason's gain formula, that is P1 del 1 plus P2 del 2 plus so on by delta. That is the overall determinant of the signal flow graph. So if we use that, we have the transfer function, that is x2 by x1, which is nothing but 5 over zero point 0.5, that is the 10. So how we can get, so let us see P1 del 1 by delta. So we have P1 equal to 5 and del 1 equal to 1. So 5 into 1 by delta is zero point 0.5. We have 5 by zero point 0.5, that is 10 over here. So this is how we can solve the signal flow graph problems. So moving on to next question, we have another signal flow graph over here. So let us try to solve the problem involved in this. So yeah, we have this signal flow graph which is being given. So we have to find out the overall transfer function for this signal flow graph. And first step one is to find out the forward paths, how many forward paths are there. So by observing keenly, we have two paths over here, that is from 1 2 3 4 to 1. this is the one path, and we can go to input node to output in another way, that is 1 and to 5 into 1. So that is being discussed over here. That is 2 into 3 into 4. This is the straight path which is having the path gain of 24, and this curved path over here that is being shown 1 into 5 into 1, that is forward path gain P2. And here we have completed the forward path gains. So we have to find out the loops in this signal flow graph. We have four loops. You must have identified three of them. Where is the fourth one? That is very easy. So let us see. So we have this first loop 2 into minus 1, which is minus 2, and we have the second loop 3 into minus 1 minus 3, and we have this third loop 4 into minus 1, which is minus 4, and we have another loop which starts at this node, and if we traverse along this path, that is 5 into minus 1. So 5 into minus 1 is minus 5, and into minus 1 we have another minus 1, so plus 5 over here, and into minus 1 we have another minus 1, so minus 5. That is the fourth loop we have. So remember, a loop should travel in the direction of arrows, and it should reach the origin of the place on origin of the loop. So we have four loops over here. So we have two forward paths over here, so we must have two isolated determinants. So first forward path, so that is the straight path. If we find out this isolated determinant, like if we isolate this first forward path, then nothing will be left. If we isolate this first forward path, then nothing will be left. So sorry, nothing will be left because all the nodes are vanishing. So we have the first determinant, that is 1 over here, so all the loops are vanished. So let us kind of remove the second forward path, that is second based on removing the second forward path, we have we have this as the second forward path. So if we remove this node and this node and this node and this node, we have two more nodes left. So then we can have a loop over here. So in this case, the isolated determinant cannot be zero. So how we can solve that? So isolated determinant is 1 minus the sum of isolated loops. So we have only one isolated loop of gain minus 3 over here, that is the L2 loop. So if we substitute this, we have the isolated determinant from path 2 is 4. So and using this we can find out this isolated determinants. So coming to the determinant of this entire signal flow graph, we have 1 minus sum of individual loop gains. So we have four loops. So minus of minus we can get plus. So sum of this individual loop gains will give us 2 plus 3 plus 4 plus 5, because these are individual loop gains and non-touching loops. So if we see, we have two only one pair of two non-touching loops. That is this loop one, which is being two, which is having loop gain of minus 2 over here, and this loop 3, which is having a gain of minus 4 over here. If we if we do this product of these two loop gains, we will get a plus sign. So if we add this 2 into 4 with this total, we have the determinant of 23. So using this Mason's gain formula, that is the forward path gain into corresponding determinant plus forward path gain into corresponding determinant divided by whole determinant of the whole signal flow graph. If we do that, and the first forward path gain is 24, that is the straight line. So we have seen that, and the corresponding determinant is 1. If we remove all the nodes, we are left with nothing. So that this isolated determinant became 1, and P2, and that is the curved path we have seen. So if we remove this curved path P2, then we have a determinant 4. We have already seen that. Based on these calculations, we can find out the overall transfer function as 24 plus 20 by 23, which is 44 by 23. So that is how we can find out the signal flow graph, and we can solve the overall transfer function of a given signal flow graph. Thank you guys. If you are new to our channel, please do subscribe to our channel, and for more interesting and content, please do subscribe to our channel. Thank you guys.